Just a quick test of the audio to see if something is coming through. Well, I make it 7:30, so I'm going to start this talk. I hope nothing goes wrong. I've given at least one of these talks where I forgot to turn the microphone on, so I'm hoping that's worked okay here. I'll quickly glance to the left to see if anybody is screaming, "I can't hear you." Otherwise, well, welcome to Birmingham Astro's seminar for today, given by me, all about the far side of the moon and is it just aliens? So an interesting topic, a little off my normal list of topics, but we'll see where we go with this one. So anyway, thank you for turning up, those of you who have, and I hope you're all staying safe and well. So let's start. The far side of the moon. Is it just aliens? So I wanted to make this talk about the far side of the moon because we know quite a lot about the near side of the moon. We've all looked up at it, I'm sure, and seen the near side of the moon because the moon only ever shows one face to us. So that is really all we see. We just see this singular face, and that's what we're all familiar with. So the far side of the moon we've never seen really before the space age. So it's obviously going to be a place where conspiracy theorists can run wild and think, well, what is the universe trying to hide from us on the far side of the moon? And it's taking us quite a while to get to where we are and actually see some of it. So it's going to be a bit of a mixture, this talk. Some of it is sort of the science of the moon, and some of it's about the exploration, and some of it is all about the conspiracy theories that have grown out of it. So I hope you find some of it at least interesting to you. So we have seen the near side of the moon, and we've even touched it, despite what definitely some conspiracy theorists think. Here's a picture of the moon with the landing site of the 6 Apollo landings that we know about. So we have touched it, we've brought bits of it back, so we're fairly familiar with it, and we do know it exists. The far side, however, and this is actually a picture of the far side, is always been a mystery because up until really the last 50 or so years, maybe a little longer, we haven't been able to see anything of the far side of the moon. So all manner of things could be hidden, and this hasn't stopped people exploring this idea with absolutely zero knowledge of it. So here's a headline from a while ago saying that a giant alien castle was found on the moon by UFO experts, whoever they were. So this is from 2016. This is the alien castle. So you can clearly see there the alien castle with all its residents. Or perhaps you can't, I don't know. Here's a blow up of it, seeing the alien castle. Most of these things turn out to be either artifacts or something slightly more modern called Photoshop, but we can come back to that. Of course, going back, so this is back in, when is this, 1970s? No, 1980s, I think. World War II bomber was found on the moon, the Sunday Sport, that bastion of a journalistic enterprise. Try not to read any of the other headlines on this page. And they had a picture of this World War II bomber that was clearly found on the moon. You can I think see there the World War II bomber. Now, they did have some very clever blow-up technology and managed to enhance this and zoom in on some of the detail. And here we can see the full picture of the World War II bomber, and it looks to be like a B-17, but I'm willing to be corrected on that. One thing that you might notice from this is the size of the crater, which is probably several kilometres across. So that plane is hugely out of scale, but that's never going to stop a good story, is it? There's been various films, Transformers, Dark Side of the Moon. Yeah, it's a great place to put anything that you don't want the general public to see, because you can store it there and nobody will see it. But it goes back many years, back in the 2 centuries ago, in fact, 1830s. There was the Great Moon Hoax, perpetrated by the New York Sun newspaper and Sir John Herschel, although Sir John Herschel, who was actually in South Africa at the time, mapping the southern stars, knew nothing about it. But they claimed that Sir John Herschel had got a new huge telescope and could now look in detail on the moon, and we see these pictures. I think they ran it for about a week, showing these various fantastical pictures of what was happening on the moon all through this fantastic telescope. I imagine he must have been fairly miffed when he got back from South Africa and found his name had been taken in vain. Anyway, there we go. This just shows you there's nothing new under the sun. Of course, the other clear one is The Dark Side of the Moon, that iconic album by Pink Floyd that was sort of mandatory ownership, at least when I was growing up. I'm sure most of you have either heard it or probably own a copy of it. But it does end with the nice words right at the very end. It says, very quiet, actually, after the heartbeat fades out, it says, "There is no dark side of the moon, really. As a matter of fact, it's all dark," which was recorded as part of the album and put onto it, actually by the doorman of Abbey Road Studios. That's where they got the recording from. And I've forgotten his name, but somebody can, or you can Google it later. But as I say, there is no dark side of the moon, really. It is all dark. Well, it's all dark and light. It's a 14-day period, the moon, so for 14 days it's in light, and then 14 days it's in dark. So let's go back right to the beginning, the formation. Our best idea of how the moon formed is there was a big collision between something about the size of Mars and the infant Earth, so over 4 billion years ago, right at the very early stages when planets were being formed. This protoplanet crashed into the Earth and knocked off large chunks of it that went into orbit. We would have probably had rings for a while, and then these coalesced down into a moon. This is an animation that was done at Boulder University, showing what the collision might look like and how all this stuff flew off it. And this would explain quite a few things, one of which is why the geology of the moon, at least the surface geology of the moon and the Earth, is very similar. It's because they are actually made of the same thing. So that's how we think it starts. It's still subject of some debate, so don't take this as gospel, because apparently the angle of impact has to be just right for this to work. If it hits it too full on, then the Earth cracks apart and we never get to where we are. And if it just glances off it, then it glances off and goes off into space somewhere. So why do we only see one side of the moon? Well, this is down to something called tidal locking, and this is not unique to the moon. Lots of objects do this. If it's a very large object being orbited by a much smaller object, often one can tidally lock the other so that it only ever shows one face. This is shown a little bit in this very extreme version of it. So there we have the Earth and the moon, and you can see there the moon are deformed into an ellipse with bits pointing towards the Earth. So the moon makes tides on the Earth. So we have two tides, one on each side, caused by the moon's pull. So the moon just pulls on the Earth, sort of bulging out the sea at this side, and likewise there's a sort of alternate sort of anti-pull on the other side. It's a difference in gravity that causes this, and those tides move around the Earth, so we get high tides twice a day from that. You don't get the same on the moon, obviously, because it doesn't have any water, despite areas of it being called seas. But you do get bulging out of rock, so the Earth pulling on the moon makes the nearest point bulge out towards it. And if the moon was rotating, as it surely did at one stage, you can see there that as it rotates around, this bulge sort of moves away from the Earth and it will fall back. But in the meantime, there's a bit of a drag force on it to the nearest point, which slowly slows the moon down, essentially, opposite of energy. And eventually it will settle into this nice stable pattern where one side is always pointing towards the Earth. It hasn't stopped the moon rotating. The moon is still rotating, as we can see in the next slide. So here's the moon going around the Earth, and if you watch the moon, you'll see it actually rotates once for each time around. Hoping that's coming out okay over YouTube. But it's actually rotating once for each orbit it does around the Earth. So it's a synchronous movement of the orbit coinciding with the rotation. This happens, as I say, for lots of things. So for a long time we thought this happened with Mercury and the Sun, that the Sun was large enough to stop Mercury spinning and actually put that into a tidal locking. But it turns out it doesn't actually do that. It nearly does it. I forget which way around it is. I think it's twice Mercury rotates for 3 times the orbit, or it could be the other way around. I know it's a 3-2 resonance anyway. So it's sort of got into that state and it's now quite stable. But certainly when we look at exoplanets around other stars, they're often quite close into the star and they often get tidally locked, which does limit its habitability. Because if one side is always pointing at the sun, or its sun, then it gets extremely hot on that side. And likewise on the other side, it gets extremely cold. And if you've got any sort of atmosphere, then you'll get very strong winds going from the hot side to the cold side. So for all sorts of reasons, there's problems with habitation if you're tidally locked. But because the moon doesn't move in a perfectly circular orbit, we actually have a sneaky way of looking at slightly more than half the moon's side. So you can see there when it's sort of at the very top here, at this point here, we're facing the Earth, and at this point we're also facing the Earth. But when you're halfway round, you haven't had, because it's not circular, you can't face the Earth all the time, so it slowly drifts away and then back in to sink. So it's something we call libration. I've got a nice slide of that coming up. It's also very slightly tilted in its orbit, not nearly as much as the Earth, but that all adds to the effect. So talking about libration, this is what, if we look at the moon over its whole 28-day cycle, you can see it wobble slightly, which is down to this elliptical orbit. So if you watch this video or animation of phases, you can see it sort of wobbling there slowly from side to side. So you can actually see something like 60% of the moon over its orbit. So just at certain times, the craters on the very edge of it get to be seen, and you can actually map, say, getting on to actually 60%, but largely the far side is unobservable. So what have we done about seeing the far side? Well, we've had quite a few missions to go and look there, starting very early on. Now, one of the problems with looking at the far side is if you put something on the far side, it's very difficult to get anything back from there. So here, if we land something on the far side of the moon, you've now got a large chunk of rock called the moon in between you and the Earth, and radio waves obviously won't go through solid rock of that dimensions. So that's the first issue, is if you put something on the far side of the moon, you can't really communicate with it unless you've taken other steps. So what other steps can you take? You can put an auxiliary satellite, and you could park that somewhere, such as out here. But the trouble with parking it here, quite a distance from the other side of the moon, so that there's enough sort of room to peer around it and bounce the signal off the satellite and back to the Earth, is that if you put the satellite there, it's now in orbit around the Earth. So it won't stay there. It will go into orbit around the Earth and move out of position reasonably quickly. So that's not a good solution if you put in something there, unless it's just for a few minutes. You could put it much nearer, but then it would be influenced by the moon's gravity and it would go into orbit around the moon. So that's certainly a possibility, but you only get to communicate with your lander or device on the surface of the moon for a part of the orbit, and at that part you can't communicate with the Earth, so you have to store up all the data and then beam it back to the Earth. So that's certainly another way that you could do it, but it's not very real time. So that's another issue. You could do it with putting lots and lots of satellites there in orbit so that they could all sort of bounce around, but that's getting quite expensive now in sort of hardware that you've got to send to the moon just to get around that. So that's one of the issues with it. But there is luckily a sort of scientific answer to this. There are certain places between the Earth and the moon where you've got stable orbits. These are sort of places where the Earth's gravity and the moon's gravity combine, so that if you put something at one of these places, I've labelled L1, 2, 4 and 5, these are called Lagrange points after the mathematician Lagrange who did some of the maths on this. They're sort of places where, as I say, so for instance L1 here, this is a place where the moon and Earth's gravity sort of cancel each other out, so whereas the satellite would try and drift off there, there's enough force from the moon to sort of keep tugging it back. So if you put something there, it sort of stays there. This would be a perfect place for a hotel on the way to the moon, because you could park this large hotel there and visit it on your spacecraft, stop there overnight or something, and then go onwards to the moon, because it would just stay there. It wouldn't keep drifting away. L2 is a very favourite place because it's the other side of the moon, and that's another place you can stop, and satellites more or less stay there. They have to be sort of nudged back into place, but it's only a little nudge compared to any other place. So that's a very good place to place satellites. Any two bodies have this property, so it's also true of the Sun and the Earth. They also have these L1, L2, L4 and L5, and this is a very common place, this L2, for space telescopes. This is where the James Webb Space Telescope is going, and where quite a few other the big space telescopes live, because it's nicely out there, out beyond the Earth, shielded from the Sun somewhat, but always in communication. If it was in orbit around the Sun, then it would eventually drift behind the Sun and we'd be out of communication. So L1 is a good place between the Sun and the Earth for putting solar telescopes. L4 and L5 are they sort of follow along behind the planet. They're actually much further out than I've drawn them here. And in case you're wondering where L3 is, that's way off this way, sort of counterbalances the Earth, counterbalances the moon in this case, and is not particularly useful for anything particularly. So we haven't found a use for L3 yet, but it's another place you could park things and they would stay there. So what have we done with the moon? So this is a bit of the history of us getting there. So Luna 1 was the very first spacecraft to actually get anywhere near the moon. Luna 1, 1959, a Russian probe sent to the moon. It was intended to crash into the moon, but they missed. But given the time, that was 1959, very soon in the era of the space travel. It was a very heroic attempt, but it was the first object of human manufacture to get anywhere near the moon. So it got very close to the moon, but missed it in the end. Luna 2, however, improved on this in 1959. They did get to the moon and crashed into it. So that was the intention, and that made it so. That was the first ever body built on Earth to actually touch the moon, Luna 2, 1959. And this was followed up by Luna 3, which did get to see the far side of the moon. So this went around the far side and brought us back this first picture, which you can see there. Not very clear, I have to say, not a lot of detail there, but nevertheless, it was the first time anybody in the world had seen the far side of the moon indirectly through this satellite that went there and took pictures of it. So it was enough for them to actually make an atlas of the far side of the moon, interpreting these structures from the very fuzzy pictures that were taken. Remember, this is quite a long time before era of digital photography, so these were often wet film that was developed and then digitized and scanned back, or similar things, taking scans and then sort of a fax image sent back over the airways. The next one was Zond 3. This was another Soviet mission. This was intended to go to Mars. It didn't actually go to Mars. Well, it sort of did, due to it launching late because of issues with it. It did go off to where Mars was, but by the time it got to where Mars wasn't there anymore because Mars had moved around in its orbit. But nevertheless, it went off out to Mars, but early on it went past the moon and had a much better camera, so we took some pictures of the moon with this in 1965. Took 25 fairly reasonable pictures of the far side, of which this is one of them. You can see here it's a much better image of the far side, and you can actually tell somewhat from this that it does look quite a bit different to the near side. This is still a mystery, which I'll come back to. We can't see there any of these sort of Maria, the seas, Sea of Tranquility, Sea of Storms, or Ocean of Storms, or whatever it is. Things like that, those big flat plains that we see on the moon, which we sort of know and love. We can't see any of those on the far side. So that was the first surprise. What perhaps wasn't so surprise was there were a few glitches in the photographs, and things like this showed up. So immediately we have a conspiracy that there's something strange happening there. Clearly aliens have landed. There's one of their giant rockets that was seen there. Or perhaps it's a sequence of monoliths. That was another idea at the time. The next sort of attempt was Ranger 4. This was going to go to the far side as part of the US space program, Ranger 4, to go to the far side. And it probably did get to the far side. We're not quite sure, because it had a computer failure very soon after it got into Earth orbit, and no solar panels were deployed. So we didn't hear anything more from it after it set off to the moon. So it probably crashed into the far side, but we don't really have any definite proof of that. It would be a very small impact crater, and if we knew exactly where to look, we could perhaps look for it, but because the moon is pretty big, it's not something we found as yet. So Ranger 4, a bit of a failure in some sense. Onwards, Luna 9. This was the first soft landing on the moon, on the near side this was. So this was, again, a Russian probe that landed rather than just crashing into the moon. This one did a soft landing and managed to send back some data from that. Luna 10, March 1966, was the first lunar satellite to actually go into orbit and do some serious work. They discovered quite a lot of things. They discovered mass concentrations, which were sort of very dense lumps of things. It also contained a sort of a playback of a famous Russian tune called the Internationales, which was supposed to be broadcast to the Communist Party during its meeting, but it's sort of failed, and they had to sort of make up for it. It worked the first time they did it, which was a test the night before, but it failed on the second attempt. Then things are getting quite serious because now it's 1966-67 and we all know what's coming up with the Apollo landings. So the Americans sent the lunar orbiter programs, lunar orbiters 1 to 5, to make very detailed maps of the moon, specifically on the near side to look for landing sites so they could get high resolution images of places they intended to land. This was based heavily on spy satellite technology, so stuff they'd been using to sort of in testing to look at the Earth, they now turned to the moon to map it in detail and work out where they were going to land. Yet again, throw up more conspiracies. So here we see the tower and the shard that were picked up in some images, almost certainly artifacts in the image processing. But that doesn't stop a good conspiracy theorist that there was clearly something out there hiding on the moon, waiting to, or continually spying on us. The next big jump, Zond 5. This was another of the Zond program of Soviet satellites. This one went around the far side of the moon. And this one was famous because it went around the far side and it came back and actually landed back on Earth and carried with it some passengers. So 2 Russian tortoises, some wine flies, a bunch of mealworms, some plants, some seeds and bacteria. So these were all packaged up into this space probe, sent around the far side of the moon and then back to Earth and landed there. And all occupants were alive and well on the return. So this proved that you could send living things to the far side of the moon and survive, which was going to be probably good news because all the astronauts who were going to go there were going to have to do that. I imagine they were fairly sure that there was nothing hazardous there, give or take a few aliens with ray guns. But it's always better to know for sure that living things can survive on at least the environment around the far side of the moon. So the 2 tortoises, Siberian tortoises, they landed quite hungry because they hadn't quite packed enough food for them on their mission. But other than that, they lost a little bit of weight. But other than that, everybody was happy. But at this point, the space race really has to kick off because up till now, the Russians have really done all the running and the Americans are so far behind. If you just look at the list of achievements, the first satellite, Sputnik 1957, I don't know if anybody listening was around at that point, but that certainly shook up the world when that was launched. The first lunar probe, we talked about Luna 1 in 1959, first thing to get to the moon. First lunar contact, Luna 2, that we talked about. First spaceman, Vostok 1 with Yuri Gagarin, 1961. The first space woman, Vostok 6, Valentina Tereshkova, Vostok 6, 1963. So yet another first. The first lunar soft landing, Luna 9. And the first lunar satellite, Luna 10. So up till now, all the records are in the Russian book. So the Americans have to pull off something fairly spectacular to reclaim the space race, essentially. So we come to the Apollo missions. I'm not going to talk too much about these, except where they sort of impact the story, because there's lots of very good talks about the Apollo missions by people who know far more about it than me. But I'll just skate over a few of the bits. Unfortunately, it all starts with tragedy. The very first one to be called Apollo is Apollo 1, and this wasn't actually called Apollo 1, except it was sort of renamed that in after the event. So this is Grissom, Chaffee and White, who were on the launch pad in this capsule, just undergoing a test where they filled the capsule full of high pressure oxygen to test certain of the systems. It was never going to fly or anything like that. They were just sort of checking out some of the things. Unfortunately, some of the insulation around the wiring was not of the highest standards, and there was a few sparks created when they went under this test. Most of the things in the capsule were supposed to be fireproof, but they weren't necessarily fireproof when at a much higher pressure than normal and pure oxygen. So it was under those circumstances that the fire sort of caught hold and burned very quickly through the capsule, killing all 3 astronauts very quickly. Another contributory factor was the door of the capsule couldn't be opened very quickly. This was down to one of the earlier missions of Gemini, actually with Gus Grissom, the astronaut on the left there. His capsule landed in the water, and there were explosive bolts attached to the door. And nobody is ever quite sure exactly what happened, but the bolts blew and the door opened and the capsule sunk. But Gus managed to get out before that. So after that, they redesigned the door so that it was a bit less of a hair trigger, so that this didn't happen. But then that was a bit of an issue here. So that was 1967, and had John Kennedy's strong words of, before this decade is out, we should land a man on the moon and return them safely. So 1967, it's all going very pear-shaped, and a great tragedy for these 3 astronauts. So this is the red line here, the January 27, 1967. That was never actually, that was originally AS-204, later renamed Apollo 1. There we could see some of the test launches, all the ones up to there from AS-101 to Apollo 6. They're all unmanned launches, just testing things out. So we've got the Saturn 1 various tests, and then the Saturn 5 test of Apollo 4, unmanned, Apollo 5, and Apollo 6. And then we get to Apollo 7, which is the very first manned flight of the Apollo missions. So this is the first time they put astronauts on board and launch it into space. And here is Apollo 7. So very first test of this brand new spacecraft with all the bits and pieces to support 3 astronauts for a journey to the moon. So obviously the first test is something quite simple. They launch it into Earth orbit. It goes around in Earth orbit. They do a few tests of the systems, check that it all works, and also check that they can deorbit and get back into splashdown and land back on Earth. So a good first test. Apollo 7 successfully gets into orbit and back. So what do you do with your second test? And this is where I still take my hat off. This is just so audacious. The second test, Apollo 8, they send it to the moon and back. So, I don't know that we're quite this gung-ho anymore, but we probably test things a little more rigorously these days. I'm not sure. But this was the second all-up test of the Apollo mission, and they went off to the moon and back. So these were going to be the first humans to ever see the far side of the moon for real or live, whatever. So it still takes my breath away that NASA was sort of brave enough to do that. So this is what they did. They went into orbit around the Earth and then did the translunar injection burn to go from the Earth to the moon. It takes about 3 days. They orbited the moon a few times, took lots of pictures, including this very classic one of Earthrise as they came around the backside of the moon and saw Earth rising. So they were the very first individuals to see the far side of the moon. And as far as I know, they saw no aliens. I'm sure there are conspiracy theorists who will claim they have, and it was all hushed up. If you want to know the gory details, that's exactly what Apollo 8 did. Went off to the moon, went around, did a burn to get into lunar orbit, and then another engine burn to get back to Earth and safely landed. So that was Apollo 8, first people to see the far side of the moon. Apollo 9 was really a test of systems. Apollo 7 and 8, they didn't have a lunar module aboard. And one of the issues is that you have to go into a docking phase with the lunar module. That's actually contained in a different place. In fact, if I just switch to full screen for a second, hope this works. Hope you can all see me there. I have a little prop over here. So here we have a Saturn V Lego rocket, just to show you the full extent of it. There we go. A great model. I think Lego are still producing it, but they're stopping it very soon, or they may even stop now. But if you're still in lockdown, there's a perfect task for you to do. Now, this is actually where the lunar module sits, in this part here. And this is where the crew sit. So they have to they break this part apart, turn around and come back and pick up the lunar module. So that's where that procedure was going to be tested with Apollo 9. I should just put that down for a second. Go back to the talk. So that's Apollo 9, a full test of, can we pick up the lunar module? Can we dock with the lunar module? Can we transfer people between the lunar module and the command module? Can we go through all those things that we're going to need to do when we get to the moon? Best we work the bugs out in Earth orbit rather than around the moon or something like that, where things are a bit more tense. So then we go on to the next mission, which was Apollo 10. This was a full-up dress rehearsal for Apollo 11. So they took the lunar module, they took a command module, they went around to the moon, they put some astronauts inside the lunar module, they flew it down to very close to the moon. I think it was like 50 kilometers, something like that, really close. And then they came back up and docked again with the service module and then went back to Earth. But you do have to worry a little about this, because if you were a gung-ho astronaut, you've been flying state-of-the-art planes forever, you knew you probably had very little fear about flying anything new at this point because they'd all been test pilots for many years. So if you've got two gung-ho test pilots in a lunar module going down to sort of 50 kilometers above the surface, you've got to be quite careful that they don't just nudge each other and say, come on, let's just go and finish this thing and land. So very carefully, NASA didn't give them enough fuel to actually land and make it back. So it was a full-up test of the system, and yet again, another two astronauts saw the far side of the moon. And then, of course, we got Apollo 11, which everybody knows about, safely land on the moon, sets up some science experiments, pick up a load of rocks, and then they come home again. And the very last mission was Apollo 17. Apollo 18, 19, and 20 were planned, but they increasingly got cut due to budget cuts because it kind of wasn't making the news it used to. After you've got the first man on the moon, the second and third and fourth missions to the moon are not quite such good copy. So, and it was costing quite a substantial amount to send all these missions to the moon. But Apollo 17 had a geologist on board, and Harrison Smith, he argued strongly that they should go and land on the far side of the moon because they explored the near side in the previous 5 landings. So let's go somewhere different. We know the far side of the moon looks substantially different to the near side, so why not land there? In the end, NASA probably went for the sensible option and said, well, due to all these sorts of issues with communication with the far side and how difficult that would be, and also given it's the last Apollo mission, let's be cautious here and just go for something we know how to do. So they went to the near side again. So yeah, afraid not. However, this whole Apollo thing, you might have thought that would be an end to the idea of aliens in the moon, but oh no, that doesn't keep a good conspiracy theorist down. So one of the things to research was that the idea of the moon was hollow and was actually a very large spaceship that was flown here by extraterrestrials. and harboured intelligence hidden behind spots of rock. So they were still going with the idea that it was a sort of a not man-made but alien-made structure that was carefully watching. And they were helped somewhat by perhaps incautious phrase from Apollo 12. So after Apollo 12 had landed and returned, they jettisoned the lunar module and impacted it or crashed it into the moon just to sort of get rid of it, and also as an experiment because they had seismometers both from Apollo 12 and 11 that could pick up the impact, so they could work out something about the structure of the moon. But somebody was quoted as saying the moon rang like a bell for over an hour after this impact by the lunar module onto the surface. So naturally, what properties does a bell have to ring? It has to be hollow. You don't get a solid bell to ring. So this is why this was still brought back these conspiracy theories. And also in history, we'd known a little bit about it. Edmund Halley proposed that the Earth was hollow, something that I think was followed up with Journey to the Centre of the Earth. But this was down to a mistake by Newton. He got the relative masses of the Moon and Earth wrong. So Halley suggested the only way this could be right was if the Earth was hollow. When the sums were done correctly, the Earth could once again be solid. But followed up by H.G. Wells, he had a hollow moon in his famous science fiction book of The First Men in the Moon. They landed on the moon and then went inside to meet the moon people. So there's a certain level of that. But it was given some sort of credence by these two gentlemen from the Russian Academy of Sciences. They were both Russian scientists, and based on some previous ideas, Shklovsky, 1966, claimed one of the moons of Mars, Phobos, was hollow. They suggested that the moon was hollow and a spaceship, much like the image we saw earlier. And they published this not in a scientific journal, but in something more akin to, if anybody remembers it, the Reader's Digest. I think it was called Sputnik, and it was a sort of publicity machine of Russian PR. But they sort of made lots of articles there about how wonderful life was in Soviet Russia and so on. And they published this article about how the moon was hollow and probably a spaceship. So conspiracy theorists would love this. If two academics were also suggesting it was hollow, then why not? And you can actually get a book on Amazon if you wish, entitled Who Built the Moon? And the Daily Mail suggested that these two gentlemen are clearly suggesting that the moon is completely improbable and must have been built by some extraterrestrial civilization. So, alive and well, I did wonder about buying that book for the purposes of this talk, clearly, but in the end I decided not to. And of course, could be that's no moon. We could be sitting there with a Death Star. But I think all the evidence is against it. Since the days of Apollo and soon after, we haven't done a lot with the moon. The next really significant thing to look at the moon, and particularly the far side, was the LRO, the Lunar Reconnaissance Orbiter, launched in 2009 and still orbiting the moon. This time with high precision digital cameras. So we have very, very good maps of the moon now on both sides. And it has two cameras at least. That one is a general mapping camera and another one is a very high resolution camera for looking at certain parts of the surface in more detail. Obviously you can't look at it all in that detail. But here we go. So this is I think this is Apollo 17 landing site. So you can see where it landed. You can see the tracks from the moon buggy, where they set up the experiment, even the footprints of the astronauts, and the final parking spot of the lunar rover. So if we know exactly where to look, you can train a a very high resolution camera on that part to get some very good images of what's on the moon. So now we have a really good picture of the far side of the moon, and that's shown here. This is done from the moon mapping. Just scroll up across it, you can see it's very different to the near side. There really are no seas to talk of, just a couple of flat spots here and there, but largely just very cratered, and you really struggle to pick out anything like the man in the moon. We've, say, not really gone back to the moon for a while, but some people who have are the Chinese, with Chang'e 3 originally, which was a near-side mission, but more recently Chang'e 4, which was a mission to the far side, and the very first thing to do a soft landing on the far side of the moon. And it also contained a lunar rover. Yet again, conspiracy theories are not completely convinced by this, but I think we've got fairly good evidence it is. Chang'e 4 comes from Chinese folklore. You can see that image on the right. Whereas we see a man in the moon, the Chinese folklore is that there is a rabbit in the moon, and he has a mortar and pestle, and he makes potions there. And some of the terminology for their mission comes from this ancient folklore of this story way back in time, which I'll do my best to not murder too badly, but this is what I understand of their folk tale. So back in the day, I don't know how long ago, a couple of thousand years probably, China was being ravaged by a big heat wave, which was causing enormous drought. And this was caused by 10 suns in the sky, something that I'm not entirely sure how came about. But anyway, they to sort of assuage this drought, this famous hunter called Hu Yi was tasked by the King Yao to go and reason with the suns and to stop them from drying up all the lands. And as he was a famous hunter, he actually went out and shot down 9 of these suns and returned the land to harmony and everything else. And for this, he was granted a magic potion that gave him immortality. So here is his potion. So 1 drink of this and you're immortal and you live forever. However, he wasn't 100% sure about drinking this because he was married to his wife, who he loved very much, clearly. So he wasn't too sure whether to drink this or not, because then he would never see, he would outlive his wife and so on. So he probably did what a lot of men do and put it on the shelf and thought about it a little. So his wife was Chang'e. So he left it there and then went on about his business and sort of mulling it over. But meanwhile, his understudy called Pang Meng, yes, it's up there in front of me. Yes, his understudy thought, well, if he's not going to drink it, I wouldn't mind living forever. So he broke into Yi's house and went to go and grab the potion off the shelf and drink it and become immortal. Chang'e saw him do this and managed to get there first and drank it down to save him, to stop him drinking it. So she became immortal. And because I'm not quite au fait with what happens next, one of the side effects of drinking this potion was that you then have to go and live on the moon. That was one of the side effects of that. Don't know quite how that comes about, but it's probably down to this rabbit making this potion on the moon. So this is where all this sort of folklore comes from, and it does feed back into the talk, I promise. But one of the problems with this was that then they never got to see each other. So Chang'e was on the moon, Yi was on the earth, but the gods granted them a favour and they built a bridge once every year, made out of magpies, obviously, that connected the Earth and the Moon, that they could walk across and meet up for one day each year. So that's where that comes from. And you can see there the two pictures of the man in the moon and the rabbit in the moon. So how does that bring it all back? This is what they did. So Changi was the mission. So that's the Yi's wife who drank the potion. Kweo is the satellite in this L2 orbit that we talked about earlier that is communicating between Changi and Earth. And Kweo is the Magpie Bridge, so that's where that comes from. And that's what we see. So here we see some pictures of it having landed on the moon from the Chinese Space Agency. And this is hopefully a video from the Chinese Space Agency. This is the rover having moved off the lander and trolling about on the moon, taking samples and analysing them. And you see there it's drilling stuff out of the moon. Here it is moving off the rover. And here's a backwards picture from the rover of the lander. So this is the very first thing to actually land on the far side of the moon successfully and send us pictures back and analysis too. So here we can see where we've landed on the near side, lots of places, including Changi 3, U2. U2 is the rabbit, I believe, the jade rabbit, and Changi 4 and U2 2 on the far side, clearly showing there's only one mission that's ever landed softly on the far side. And here we have a picture from orbit, from the Lunar Reconnaissance Orbit. I said it was still going. And here we have a picture of both the lander and the rover, both picked out there, because we know exactly where to look. And Changi 4 has actually produced some reasonable scientific data. So here we have a paper produced about the far side mantle, because they've managed, they're the only game in town, basically. They're the only people who've been to the far side to take images. And it's still going. So this was, when was this taken up to? 13th to 18th of December 2019. So as I said, the moon sees 14 days of daylight and 14 days of night. So because this is solar powered, it sort of works during the day, then it shuts down and sleeps 14 days of night, and then it trundles on a bit during the next period of waking. Changi 3 did a similar thing, but it didn't entirely successfully awake from its first shutdown. So the near side one sort of did its first day's stint, then went to sleep and didn't really wake up again. But Changi 4 was much more successful. You can see there it's moved around quite a lot, and apparently still going. But there's lots more happening on the moon now. It seems to be lots of people are going there. Chandrayaan 2 is the Indian space program attempt to land a lander on the near side of the moon. Unfortunately, it failed. They lost control of it just before landing, and it impacted at quite a high speed. But Chandrayaan 3 is in the works, so they're going to have another go at that. We've also got Israel's Bereshit spacecraft. This also went to the near side, but also unfortunately had a terminal failure very close to the surface. But you've got to think, if Russia, America, China, and now Israel and India are all sending stuff to the moon, it's got to be time we went back to the moon at this point. It seems lots of nations can go there. So just to wrap up now with a talk, and this is purely my own speculation, so you don't have to believe any of this. We still have a few questions to be answered. The first of these is really why it looks so different. Here we have the near side and the far side, and you can see they really do look very different. The far side looks far heavier cratered than the near side. So, what's going on there? We don't really have a good explanation for that. That's still ongoing research, as they say. One suggestion is the Earth protects it, that the Earth blocks a lot of things that would otherwise hit the moon's near side, but really it doesn't block very much. There's only 4 square degrees, which is a tiny part, tiny shadow of things that would otherwise impact on the moon. So it doesn't really make very much difference. What we do know is that the crust on the near side is much thinner than the far side. The far side is much thicker, probably not as extreme as this, but clearly that will have an effect. Firstly, the crust is much weaker on the near side, so you're much more likely to get eruptions and things flowing out and filling in these seas than you are on the far side. So that sort of explains some of that, but then just gives you another question: why is the near side so much thinner than the far side? And I've looked at a few papers on this, but really I don't think anybody has a really good answer to this. There's certain speculation. It could be the way it's formed, it could be the way it's settled down, it could be something to do with tidal locking, it could be all sorts of things, but I don't think anybody has a very good idea. What should we do? Was it a home for aliens? I think now we can almost certainly say it was never a home for aliens, and outside of finding large sentinel anomalies on the moon, that there is no sign of aliens on there. But what could we do with it in the future? I think this would be a fine idea. Colonization of the moon would be an excellent way of putting our first steps into space. We have the International Space Station. We've had people on that for a long time now, since early 2000s. The moon would probably be the next easiest step. It's so much easier to get to the moon than it is to get to Mars. It's a 3-day trip, basically, to get to the moon. It's a 9-month trip to Mars, and it's a lot longer to come back, because if you go to Mars, it takes you 9 months, but then you've got to wait till Mars and Earth are lined up again, which takes another year or so before you can really make the return journey in any economical way. So the moon is an ideal proving ground. You've got to solve a lot of the same problems. The moon doesn't have an atmosphere, but then Mars doesn't really have one to talk of. So you've got to solve a lot of the same problems, coping with radiation, making fuel, making habitats, all that sort of thing. It has to be done on the moon. The other thing is, if you can get industry on the moon, it's very easy to get things from the moon back to Earth, almost trivially so. This is just a quick plot. We needn't worry about the units, but in the blue, that's how much energy you need to get from the Earth off, to somewhere like the moon. That's the amount of stuff, energy. And you can see the grey bar, that's what is required from the moon. So just to compare and contrast, if I just flip back to full screen again. So this is what we needed to get off the Earth to the moon. So we needed all that rocket power to get off the moon, off the Earth onto the moon. This, to the same scale, is what we needed to get off the moon back to the Earth. In fact, only half of that. So it's really tiny compared to that. If you look, this bit fits inside there. So it's absolutely tiny. So if you can produce almost anything on the moon in any reasonable way, you might take asteroids to the moon and mine them on the moon, or make things there. It's very easy to get goods back to Earth. That's certainly one thing. Get myself back. But another thing, being an astronomer, it would be a great place for telescopes. You're not going to have any light pollution on the far side, well, at least not for 14 days, because you're going to be in the dark. It's even better for radio astronomy, because you are shielded by the Earth from all the radio waves on Earth. So, and you don't have any atmosphere to look through. So it'd be a fantastic place for telescopes. And in fact, there was supposed to be a discussion group on telescopes on the far side of the moon at the Royal Astronomical Society I think the meeting was going to be in April. Of course, it was all sort of cancelled due to lockdown, but people are now seriously looking at putting some structures of that either assembled remotely, because radio dishes are not that difficult to assemble, but even better would be to have people living there. Arthur C. Clarke, in one of his famous books, had a colony of astronomers on the moon. Had other things happening on there that made a cracking good read, but they had a colony of astronomers with large telescopes, and this was set later into this century. But all the serious astronomy was then being done on the moon because the conditions were just so much better on the moon. So that'd be a wonderful place for that. So moon telescopes on the far side. That would be my plan. So thank you very much for listening to this. This is coming to the end of the talk. So you can, if you want to type any questions into the chat, I'm quite happy to take those. There is a slight lag with this, that I'm talking and then it takes about 30 seconds before it appears on YouTube. So I'll keep talking for a bit, just to say thank you very much for listening, and I hope you found some of that interesting. But while that's going on, I see some of you quite like this model, Saturn V rocket. It's well worth building. Another interesting fact about it, there's 1,969 Lego pieces in it. So 1969 for the year Apollo was launched. This is quite rigid. You can shake it about, and it does actually. Can I get it to bits in a meaningful way? Yes. Okay. So they see the engines there and the engines there. So pretty good. Say it was just over £100 when I got it. Well, somebody got it for me. And if you're also interested in that, you might also be interested in this, which is another Lego model of the lunar module with astronauts on it. Obviously not to the same scale, but I should get money from Lego really, but fantastic. And this includes this nice drawer here that drops down. Don't know if you can see there. This is the camera that they've used. This dropped down when it landed and used to film the astronauts coming down the steps. So there's another model if you're into your Lego modeling. So if there's nothing further, I'd like to thank you all very much for listening. Hope you enjoyed some of that. It's obviously not quite as good as a live talk, but probably the best we can do under the circumstances. So thank you very much for listening, and I'll sign off now, and see you again when all this is over next year, perhaps. Bye.